All right, this is our first mini lecture for financial algebra, and we're going to talk a little bit about this important idea of inverse relationships in math. And when we're talking about a relationship, we're really saying, how do things work together? And inverse is very close to the word reverse. And so a really good example of inverse relationships in math are addition and subtraction. And the other one we're going to talk about today is multiplication and division. And then later on in the course, we'll talk about other inverse relationships in terms of math functions. So just a little bit of vocabulary. These are some very common words associated with each one of the basic math operations. And if I'm asking for a sum, I'm asking for the answer to an addition problem. Difference is subtraction. So for example, I'm 41 years old and my older sister is 46 years old. And if I asked what is the difference in our ages, it's 5 years, and you would find that by subtracting. If we're asking for a product, we're talking about multiplication. And then quotient is the answer to a division problem. There are lots of other words that you'll encounter in the course that signal you to do these different operations, but this is kind of the baseline we're going to start with. Okay, so just a quick note about symbols, because math is a language, so the vocabulary is important, but the symbols are important too. So really commonly, if I wanted to show multiplication, let's say I was going to do 2 times 4 equals 8. And really what this means is I have 2 4 times, or I have 4 2 times. With multiplication, it doesn't matter what order you do it in. But this symbol right here that we use for multiplication can get confusing when we start looking at algebra applications, because it looks a lot like the variable x. So this may come up sometimes, but mostly we're going to stop showing multiplication in this way. And the most common way that we will, just to keep things organized when we have variables and other kinds of notation like exponents and things like that, we're going to use parentheses instead. And it could look a few different ways. It could look like that, or if I just wrote it like this, that's also showing a multiplication. Or if I show it like that, that would be kind of uncommon, but that would still be multiplication. Sometimes you'll see a little dot is used to show multiplication. Sometimes, and this is the way it is on a computer keyboard, you would have this little asterisk here. And then as soon as we start getting into things with variables, let's say I had something like 4y. When things are sitting right next to each other, this would be equal to 4 times y, or y 4 times. And not to get too into the weeds here, but when we talk about the things sitting right next to each other and we automatically assume that this is multiplication, it's often said that in math, the default operation is multiplication. So if you have some values sitting next to each other and there's no other symbol telling you what to do, you can assume that they're being multiplied. Then if we look at division, we have 2 common ways when we're working with arithmetic. Let's do this one in reverse, the inverse. So if I take 8 and divide it by 4, that's equal to 2. Or if I wanted to use the long division symbol, that's everyone's favorite, I would say 8 divided by 4 is 2. But again, once we start having variables and other symbols, this gets a little bit just too complicated, too fussy. So the most common way we're going to do it is we're just going to write it so it looks more like a fraction, and a fraction is a division problem. And this is just 8 divided by 4 equals 2. So this is our division symbol right here. So just a quick note on that, because you don't want to be confused just if you can't even recognize what the operation is. And again, this is going to be most common in algebra, and the things with parentheses are going to be most common, except when we work with variables, you won't even use the parentheses. All right, so let's talk for a minute about the relationship between addition and subtraction. And we've already seen this word inverse. And I have a colleague who says it's like putting the car in reverse. So if I was driving, let's say addition is going forward, 5 plus 4 equals 9, but then if I took the car and I put it in reverse, I'm still going over the same information. Now I'm doing the inverse operation, and 9 minus 4, of course, is equal to 5, or 9 minus 5 is equal to 4. So we have this very important relationship that's going to follow us throughout all the other math that we do, which is that addition and subtraction, they're opposites. Oh, sorry, I can't spell. And this is really important for a lot of reasons. One of them is that you can always check one by doing the other. And a lot of times, if you're more comfortable with one of the relationships and not as comfortable with the other one, you can use your knowledge of one relationship to help you figure out things about the other. So let's visualize that. And this is called a T-chart or a T-table. And it should be pretty obvious why it's shaped like a big T. And this is a way of showing the relationships when we have a sum. And remember, sum is addition, but then the inverse is subtraction. And this just gives us a really neat way to visualize it that's going to help us later on when we look at some other relationships in math. So I can visualize it right here. I'm finding the sum. So 5 plus 4 is 9. But it also allows me to visualize the inverse relationship, because 9 minus 4 is 5, and 9 minus 5 is 4. And we can get a sum of 9 other ways. You know, I could have 0 and 9. I could have 1 and 8, 2 and 7, and 3 and 6, and then 4 and 5, which is the same as 5 and 4. And then in each case, we have the inverse relationship built in here, because if this sum of 0 plus 9 gives me 9, then 9 minus 9 gives me 0, 9 minus 0 gives me 9, 9 minus 8 gives me 1, 9 minus 1 gives me 8. And it's a really nice way of visualizing this relationship, and it's going to help us later on. So go ahead and pause it here, and you're just going to find the pairs of values that will give you a sum of 12. And then when you're ready, go ahead and unpause it and we'll check it together. All right, so when we're looking at a sum relationship, again, we're looking at addition with the inverse of subtraction. And we can start with 0 and 12, and 1 and 11, 2 and 10, 3 and 9. And of course, you'll note that as I add one more over here, I'm losing one more over here. And there are actually some really interesting math properties that are concerned with the fact that as I add 1 here, I'm losing 1 here. So then we would have 4 and 8 and 5 and 7. Sorry, I had to think about that for a second. And then we would have 6 and 6. And then the next one would be this one in reverse, 7 and 5. So we found all the ways that we can get a sum of 12, using whole numbers, of course. And then we can picture the inverse relationship. If 2 plus 10 is 12, 12 minus 10 is 2, 12 minus 2 is 10. So let's look at the relationship now instead between multiplication and addition. Sabrina makes $15 per hour. How much does she make before taxes in a 40-hour work week? So take just a minute. Feel free to use a calculator. That's what we do in the real world. And then let's go ahead and solve this together. Remember, you can always pause if you want to. Okay, so there are actually 2 ways that we could approach this, and this is going to show us the relationship between multiplication and addition. Sabrina makes $15 per hour, and this is a very important math word, which means for each, and in this case it's for each hour. So for example, if I say that I'm driving at a speed of 60 miles per hour, that means in 1 hour I'll cover a distance of 60 miles. In 2 hours I would cover a distance of 120 miles, because it's for each hour. So Sabrina makes $15 for each hour that she works. How much does she make before taxes in a 40-hour work week? So one way that I could approach this is I could just add 15 40 times. 15 plus 15 plus 15 plus 15 plus 15. That would work. I would get the right answer, but it would be hard to keep it organized because I'm adding it so many times. And that's where the relationship between addition and multiplication gets in. Because it's easier just to show $15 and multiply that by 40. And let's see what that's going to give us here. Oops, tried to do division. And all I'm saying here is that I have 15 40 times, and you can see that this calculator uses the little asterisks to show multiplication. And that's going to give us $600 before taxes. So think about it for a minute. What is the relationship between multiplication and addition? This is not a relationship of opposites. This is a shortcut relationship. So multiplication is a shortcut for repeated addition. And we're going to see later on that then we can build on that, and there is even a shortcut for repeated multiplication. So let's go ahead and approach a word problem using multiplication. And go ahead and pause it for a minute so that you can read it. And then as soon as you have a solution or you're ready to see me go through it, go ahead and unpause it. Marty makes $27 an hour as a math teacher, and this is another way of saying per. He works 8 hours per day and 80 hours on each paycheck. How much does Marty make before taxes on each paycheck? So word problems are an interesting beast within the world of mathematics because they're set up in kind of a funny way. We get all this information before we ever find out what we're supposed to do with it. So what I recommend, because once I get to the question, I've really almost forgot everything that I read here. I'm going to have to go back and read it again. So I want to flip it. And when I have a word problem, I always just want to identify the question first. And it's usually at the end, and it's going to have a question mark on it. So what is the question asking us to find? So how much does Marty make and this is before taxes, on each paycheck. And I can see right here it says 80 hours, so that's going to be 80 hours per paycheck. And another thing that happens with word problems is that they can be confusing because you can be given information that's misleading because you don't actually need it to solve the problem. So let's just make a list of all the information, and then we'll go back to the question and decide, do we need all that information to solve it? So let's look at the information that we're given. Okay, Marty makes $27 per hour. And I can just write it down without having to decide if I need to do anything with it. I'm just going to kind of observe it from a distance. Okay, he works 8 hours per day. He works 80 hours per paycheck. And then here's our question. How much does Marty make on each paycheck? So if I look here, there is one piece of information that I don't really need to solve the problem. And it's this one right here. It actually doesn't matter how much he works per day because the question is asking per paycheck. So we'll take his 27 that he has 80 times. And before taxes, he's going to make $2,160. And then what I would challenge you to do here is to look at this and to think, could I teach this problem to someone else? If someone read this and didn't understand it, could I explain it and could I defend my answer? And if you don't feel that you could, you probably want to go back to the information, make sure you identify the question clearly, and reorganize it and try again. But here I'm confident. I'm confident in the way that I set it up. The size of this number seems reasonable. If I got something like 21,600, I would assume that probably a math teacher does not make that per paycheck. And it probably means I hit a wrong button on the calculator. And a good idea too, this calculator is cool because I can see what I inputted. So I'm really confident in what I inputted and what the output or the result was. But if I don't have a calculator like this that'll show it to me, you might just even do it twice and make sure you get the same answer. Okay, so now we're going to move to our third relationship, and we're going to look at the relationship between multiplication and division. So if 4 times 5 is 20, then 20 divided by 4 is 5. If 3 times 6 is 18, then 18 divided by 3 is 6. If 8 times 9 is 72, 72 divided by 9 is 8, and 72 divided by 8 is 9. And something that is worth noting here, when we were multiplying and when we add, it doesn't matter what order we add in. So 2 plus 4 is 6, 4 plus 2 is 6. 2 times 10 is 20, 10 times 2 is 20. But with division and subtraction, the order does matter. There's a big difference between 72 divided by 9 and 9 divided by 72. So what is the relationship? So far, we've seen an inverse or opposite relationship. That was with addition and subtraction. And then we saw a shortcut relationship, and that was multiplication and addition. So my question to you is, which kind of relationship is this? Is this an inverse relationship or a shortcut relationship? Well, since I can go and put the car in forward, and then put the car in reverse, this is an inverse relationship. And there are lots of reasons why understanding that inverse relationship is really helpful. And one of the things that I find for a lot of students is that it's really helpful because students tend to be very comfortable with multiplication and not as comfortable with division. But you can use your knowledge of multiplication to help you build your knowledge of division. Since it's an inverse relationship, we can also picture this in a T-chart, just like we did with the sum relationship. But I know now we're looking at multiplication because I have that word product. And then our inverse is going to be division. So now instead of finding the sum, we're going to find the product. And we can always start with 1 and the product itself. And then I can just try other values. I'm going to do them in order. This is an even number, so I know 2 is going to work. But if I'm not totally sure, and if division is not my favorite operation, and I can't just see what this is right here, I'm going to use the calculator. The question is, 2 times what is 36? And if I can't see it right away, I can use the inverse relationship, and I can go 36 divided by 2, and that's going to give me 18. And when we're finding these numbers that we multiply, we call those factors. So we're finding all the factors, and that is a vocabulary word assigned to the product relationship. All right, then the next possibility would be 3. And there's actually a good trick here for seeing whether or not this does have a factor of 3, which is if you take these and add them together, 3 plus 6 would be 9, and that's divisible by 3. And that means that 36 is divisible by 3. It's kind of a cool little trick. But if I'm not sure, I can use the inverse relationship and go, okay, 36 divided by 3 does give me the whole number of 12. I'm not so sure about 4, so let me go ahead and try that. Let's see if 4 is a factor. So 36 divided by 4, oh, yeah, 4 times 9, so that's another set of factors. And 36 divided by 9 is 4, 36 divided by 4 is 9. I don't think 5 is going to work, but I'll go ahead and try it. That gives me a decimal, so that's not going to be a factor of 36. What about 6? Yes, so 36 divided by 6 gives me 6, which means 6 times 6 is 36. And as soon as I get repeated factors, it means I found all of them. So I can stop. But look what would happen next. 7 is not a factor of 36. 36 divided by 7 is 5.14, and then a bunch of other decimals. And we already know that 8 doesn't work. So the next one would be 9 times 4. But we already have it right here because remember the order that you multiply in doesn't matter. So as soon as you get a repeated factor, that means that you found all of them. And now we can picture all the whole number product possibilities with 36. 36 divided by 36 is 1. 36 divided by 4 is 9. And it's just a really cool way of keeping that all organized, which comes in really handy many, many times in math. So go ahead and pause the video, and I want you to try doing the same thing on your notebook paper or whatever you're using to take notes. You can just set up the T. We have a product of 20, which means product means we're working with multiplication, and the inverse, it's funny I keep writing it funny like that, the inverse of division. And you're going to start with 1 and the product itself, and then see if you can find the other factors of 20, the other whole number factors of 20. And then as soon as you think you have the table completed, go ahead and unpause it and we can check it together. So like 36, this is an even number, so I know 2 is going to be a factor. So I'm asking either 2 times what is 20, or if I can't see it, this unknown, 20 divided by 2 is 10. I'm not sure about 3. Let me test it. 20 divided by 3. Now that gives me a decimal, so that's not a whole number factor. What about 20 divided by 4? That works. So 4 times 5 is 20. And then the next one would be 5 times 4, but this is repeated. So we have repeated factors, which means we can stop. And we found all the whole number factors for the product of 20. All right, let's look at the final math relationship for this mini lecture. And then you'll do some activities, and then in the second part of the module, you'll have another mini lecture. So we saw the relationship between addition and subtraction. That was an inverse relationship. Then we had the relationship between multiplication and division, which was a shortcut relationship. Now we're going to look at the relationship between division and subtraction. And remember, division and multiplication, that was also an inverse relationship. So take a minute to think about this. What do you think the relationship between division and subtraction is? And I'm going to give you a little hint here. I'm going to use that old long division symbol. And I'm going to take 100 and divide it by 2. And just take a minute to think about that. So the way that I would do this is I would try to divide the smallest possible value buried within the 100 here by the 2. I can't divide 1 by 2, but I can divide 10 by 2. So the way we do the long division is I would take 10 divided by 2, and that would give me 5, which I can prove with the inverse relationship. 5 times 2 is 10. Then the way we do it, we subtract. That gives us 0, and then I bring down the other 0. And then I try to divide this that's left. Well, 0 divided by 2 is 0. And now I can see that 2 times 50 is 100. It's not my favorite way to divide. I want to actually picture it a different way, but this is the traditional way that we do long division. Well, look at the relationship here. Inside the division, we had a subtraction happening. And so what we have is that division is a shortcut. So it's a shortcut relationship. A shortcut for repeated subtraction. So remember that we had multiplication was a shortcut for repeated addition. Well, it makes sense that this shortcut relationship would be for the inverse operation of addition, because division is the inverse of multiplication. So let's picture this in a different way. So take just a minute to think about that. All right, so we can show the division relationship with subtraction by just doing this repeated subtraction. So we always say, how many times does 5 go into 20? And I want to think about it differently. I'm instead going to ask, how many times does 5 come out of 20? And that's how I think about division. How many times can I take 5 and subtract it, and do I have anything left over? So the first subtraction, I do 20, that would leave me with 15. I would do it again, and then 10, and then 5, and then we would have no remainder. So I can picture it here. I subtracted it 1, 2, 3, 4 times. And then we can check it with the inverse relationship because 5 times 4 is 20. So let's do it one more time. The question is, how many times can I take 16 out of 4? Sorry, how many times can I take 4 out of 16, and is there anything left over? So let's see. 16 minus 4, that's going to leave us with 12. And then that'll leave me with 8. That'll leave me with 4. And then I have no remainder, because I have 0 left over. So the question is, how many times did I take 4 out of 16? And what I did was I took 16 and I divided it into equal groups of 4. 1, 2, 3. Coincidentally, this one is also 4. And then we can see the inverse relationship, which is 4 times 4 is 16. And the last kind of critical thinking thing I want to think about, and then we're going to do one word problem with division, is what is this whole thing with remainders? Well, remainder, the root of that is the word remain, which is to stay or to be left over. So the question is really, how many times can I subtract, in this case, 3 from 19, and is there going to be anything left over? So let's find out. So 19 divided by 3 is just asking how many times can I subtract 3 from 19. So let's see, 19 minus 3, that's going to give me 16. I'll do it again, that'll give me 13, then 10, 7, 4, 1. And when I get to this point, I can't subtract 3 another time. Oh, sorry. I can't subtract 3 another time, which means I have a remainder. Just something that was left over. So let's see, how many times were we able to take 3 out? 1, 2, 3, 4, 5, 6 times. And we would say 6 with a remainder of 1. And we can still use the inverse relationship to check this. It's just there's a little more to keep track of. 6 times 3, well, let's see. 6 times 3 is 18, but I still have to account for this remainder of 1. I had that 1 left over, so I need to add it back in, and I do get the 19. So I can still use the inverse relationship to check this. And this is something very common when you're dealing with mixed numbers and fractions. All right, go ahead, feel free to pause it, and then let's check this one together. So the question is, how many times can I take 5 out of 26? So let's see, so I'll take it out once. That leaves me with 21, and that's going to give me 16, and 11, 6, and then I'm going to have, again, a remainder of 1. Something left over. So how many times did it come out? 1, 2, 3, 4, 5 times. Because 5 times 5 is 25, but I had that remainder of 1. So I would check it. 5 times 5 is 25, and then I would add the additional 1, and that would give me 26. This comes up a lot in fractions, but also the idea of the inverse relationships is so important when we move to algebra applications. All right, so if you didn't preview this before you watch the video, go ahead and pause it, take a minute to read this, And we're going to do this final question together, and then you'll have some other activities in the module. So just like I did in the last one, I want to identify the question. And the question is this whole sentence right here. So let's look. And I'm not even going to look at the other information first. I'm going to just identify the question, and it's okay even if I don't understand it completely. If she gives each student an equal number of cookies, how many cookies will be left over for Elizabeth to eat? Okay, so if she gives each student an equal number of cookies, how many will be left over for Elizabeth? That's our question. And even though it's kind of time consuming, in the end it does actually save you time to write the question down, because there is a direct connection between what you write and what you learn. And a lot of times if I am reading something and I don't understand it, all I have to do is write it down and it becomes more clear to me because my brain made a different connection. All right, then let's look at what information do we have. Elizabeth bought a bag of delicious chocolate chip cookies to share with a study group of math students. The bag has 30 cookies in it. All right, so we have 30 cookies in a bag of chocolate chip cookies. The bag of cookies cost $4.99. And there are 4 students in the study group. So think about this for a minute. Is there any information that we don't need to answer this question? And in this case, it's the cost. There's nothing in the question that has to do with the cost at all. We're just looking at how many students are there in the group, how many cookies are they going to get, and how many will be left over for me. So this is 30 cookies divided by 4. And then we're going to see if there's a remainder for me. So we could do it by subtracting, and let's go ahead and do that. So I've got 30, and I'm worried I'm not going to have enough room, so let me do it over here. So we have a total of 30, and the first time I subtract 4, I'm going to give 4 cookies to, or I'm going to give 1 cookie to each of the 4 students. That's going to leave me with 26. Then I'm going to give another cookie to each of the 4 students, and that's going to leave me with 22. Another cookie to each of the 4 students leaves me 18. And then each time I give them cookies, and now I don't have enough left over to give an even number to each person. I have this remainder of 2. And that's going to be the amount that's left over for me, because I'm not going to just give 2 students more cookies. I want to give everybody the same amount. So I was able to give 1 cookie to each of the 4 students how many times? 1, 2, 3, 4, 5, 6, 7 times. So we had 30 divided by 4. That's equal to 7 with a remainder of 2. And the 2 is what's left over for me. And we can check it because 7 times 4 is 28, and then if I add the 2 that I eat, that gives me 30.